Hello, my calculus people. Today I'm going to talk about implicit differentiation, right? Differentiation is a fancy word for take the derivative of, right? So implicit differentiation is going to be weird. We haven't done this. We could have been doing it the whole time, but I didn't do it because it was just a lot more writing, and there's no need to do it. Because so far all of our equations have been we've differentiated, or taken the derivative of, have been written in explicit form. You may be wondering, okay, good, what is explicit form? And I'll say, well, you know what explicit is. It's when you use foul language in songs as explicit content. No, explicit is when it's in y equals form when you start a problem. Everything we've done has been in y equals before we started it, or f of x, but basically there's only one type of letter on one side and another type of letter on the other. So for instance, if I looked at this guy, it's in explicit form because it's y equals, right? And all the other junk's on the other side. Well, what I want you to think about, and what we've been doing, we just haven't been writing because I wanted you to work on your skills. If I wanted you to take the derivative, I would say differentiate this with respect to x. That's actually the fancy way of saying it, d over dx, differentiate with respect to x. What we haven't been writing every time is you actually are supposed to take the derivative of this guy with respect to x, the derivative of this guy with respect to x, the derivative of this guy with respect to x, and the derivative of that guy with respect to x. I mean, if I really wanted to go crazy, I would do this. We probably won't do this again. But, it's worth it one time for notes, right? It's for the greater good, the greater me. Oops, that's a minus there. We'll just do that. Okay, so this is what I could do. It's sort of like distributing, but it's not a multiplication thing. You're taking the derivative of every single piece with respect to x. Now this side should be easy. We've always done this side. What's the derivative of x with respect to x? Well, it's 2x, right? Well, there's actually something else there that we haven't been writing that I'll show you. What's actually also there is I took the derivative of x with respect to x. The reason we haven't been writing it every time is guess what dx over dx is worth? Big old 1, right? That's why we haven't written it. Same with this one. I go to take the derivative of this guy, I get a 3, and I took the derivative of x with respect to x. So it goes away. This one's a 0, right? The derivative, I don't even have to write a plus 0, but why not, right? This side is weird because the letters don't match. So when you go to take the derivative of y with respect to x, well, you could take the derivative of x, just plain x, it would be a 1. Well, the derivative of y is a 1, and you have this little dy over dx. Have you seen that guy before? You recognize him? Because dy dx is the same thing that we've been writing the whole time as y prime. That's kind of crazy, or f prime of x. It means the slope at a certain point. In fact, if you're wondering why it's dy and dx, do you remember when we wrote change in y over change in x with these delta symbols that you guys love so much? Well, guess what delta is? It's a Greek letter for d. So when you're here, we have delta y, delta x. It's kind of like the same thing, dy dx. You don't have to draw any triangles or anything. So long story short, too late. I know what you're thinking. The derivative of this guy is 2x plus 3. You're like, oh my gosh, I could have done that so much faster. Why did you just waste our time? Well, 2 reasons. 1, I like you wasting your time. 2, the real reason is I wanted you to actually think about that we are taking the derivative of each piece, and you basically have this little penalty on the back. You know what you're actually doing? It's kind of like the ninja rule. You know, we learned the ninja rule? Well, what's the derivative of this? 2x. And then I took the derivative of the inside. The inside is just an x, right? dx over dx, it goes away. And I took the derivative of this, and you got a little ninja at the back of just the derivative of what letter you were using. Well, when I do this one, there's a penalty to pay. It's the little ninja, because the answer to this was 1, and it's dy dx, and it doesn't go away. Now this is useful because when you get a crazier problem, let's do another example. I'll show you an example when you have to use implicit differentiation. Like you have no choice. Sometimes you can get around it, but what if I gave you this problem? If I said, take that crazy problem, which is the equation of a ellipse, an oval, right? If you're really good at pre-calc, you recognize that, and you're like, oh, that's an ellipse. I'll say, good job, pre-calc all-star. But if I asked you to differentiate this with respect to x, and you did that d over dx thing to every piece, right? I'm not going to write out for each one, but make sure you do it to the other side of the equal sign too. A lot of people will write a 2 here. That's wrong. Okay, so we're going to take the derivative of the first number, 2x, right? Do I have to write dx over dx? No, because I know it's going to cancel. If my letters match, it's a nice, easy derivative, just like old times. When I go to do this piece, oh, it gets worse. Because when you look at this, let's skip that one for now. Let's go to the back. I'm going to skip it, just temporarily. When I go back here, I'm going to take the derivative of this guy. Now, pretend it was 4x squared. What would you do with that? You'd bring the 2 in front and knock it down 1. That's still your step. You're still taking the 2 in front, so you're going to say 8y to the first. But you have this penalty. Because the letters didn't match, you have to put this dy dx thing on it. What's the derivative of this guy? 0. Always has been, always will be. So some people like to, instead of writing dy dx, because it's a lot of letters, is to write a y prime. Oh, now I regret. I regret this little 1 I wrote up there. Just gonna write it. There we go. A lot of people like to replace this. Remember on the other page, I said dy dx is the same thing as instantaneous slope. You could replace it with y prime, just like there. Well, if you prefer, you can do this, 8y y prime, right? You can just write that guy as a y prime if you don't want to write dy dx. It means the same thing, trust me. All right, now we get to this one. This one is mean, because inside here, I don't know if you can see it, but it's a product rule. It's like you have this guy times this guy right here. So there's your u, and there's your v. So in here, when I go to take the derivative of this guy, I have to do the product rule. And you have to pay attention to which one's getting primed. Remember, it's u prime v plus v prime u, right? So u prime is going to be 2. Do I have to put a penalty on it? No, because the letters match, right? And then v, I'm just writing normal. I'm not taking the derivative, right? It's u prime v plus v prime. Where's v prime? Oh, v prime would be a 1, right? Because derivative of x is 1, derivative of y is also 1. But you do have a penalty on this guy. You have dy dx, or y prime. And then times u, which is 2x. So basically, this guy breaks down into this whole thing here. Okay, it's u prime v plus v prime u. And you just got to pay the penalty if the letters don't match, is how you want to think of it. Okay, so we get to finishing this problem off, and you're like, what the heck am I supposed to do to finish this problem off? What does my answer look like? Well, what did every one of your answers look like before? Back in the day, when we were solving problems like it was our business, your goal was to get y prime equals, right? You were supposed to get not y equals, but you're supposed to go from y equals all the way down to y prime equals, and you found the derivative. So this one, my goal is to get y prime by itself. Okay, so my first goal is I look in here and I scan for any y primes that I see. Now I see two of them. There's a y prime, there's a y prime. Anything that does not have a y prime in it needs to get out. Get over to the other side. Go on, get. So I'm going to take this guy to the other side. I'm going to take this guy to the other side. So I'm going to write this in a different order. I'm not going to write 1 y prime times 2x. I'm going to write 2x y prime plus 8y y prime. And then the other side will be negative 2x and minus 2y, because I just subtracted them over to the other side. Okay, that's cool. All right, now how do I get y prime by itself? Because this is not looking like it's gonna be like that anytime soon. And I say, but wait, remember how you can take out a GCF and they both have a y prime in common? So you are allowed to take out a y prime. I'm not doing anything to the other side yet. You take out a y prime, what's left? 2x plus 8y. Okay, I'm almost home. Because I want y prime by itself. Well, guess what's in the way? This big ugly thing. Right? So those cancel off, and y prime is negative 2x minus 2y over 2x plus 8y. Okay, that's pretty awesome. Okay, so what's cool about this is, this still means the slope of that line at any point, but what you'll notice that's different than anything in the past. It still means instantaneous slope, but now see how it has x's and y's? So you remember when we actually had a point on the graph and we're like, hey, what's the slope when x equals 1? Or what's the slope at this point? Or give me the equation of a line that's tangent through this point. Well, if I told you that the point 0, comma, radical 2 over 2 was on this line, and it is, I did it, I checked. You could plug in the x part for x and y part for y. What's kind of neat is, if I want to find the slope at this point, I don't just plug the x in anymore. Now I plug anything I see in the bottom for x, I'll plug a 0 in for, and anything I see at y, I'll plug in a radical 2 over 2. So you could plug a 0 in there, radical 2 over 2, radical 2 over 2, and calculate the slope at that point. So that's kind of cool. In general, and I'll come back with a different video where I just crank out a bunch of examples. In general, the only difference with this and the old one is you got to remember to pay a penalty anytime you take the derivative of something that doesn't match your number you're taking with respect to. The other parts work the same. Like the derivative of 4y squared is the same as 4x squared. You just have this little penalty at the back. You can think of it that way because the letters don't match. And then the only other weird thing is when you get done, and getting done means get y prime by itself. So if there's more than one, you usually got to do this GCF thing. When you're done, the answers will have x's and y's in it, which seems weird at first, but actually I thought it seemed weird. We never used to use those x and y's. So anyway, all right, I'll come back and just do some more examples and crank some out. All right, talk to you later, people.